others. So Professor Jianchun Li, he is the Deputy President of Australian Network of Structural Health Monitoring, and also he is the professor at the University of Technology, Sydney. And today he would like to give us a talk on assessing performance of alkali silica reaction, ASR affected structures, modeling and monitoring. So Professor Li, so I leave it to you.
Thank you very much, Tommy, for your introduction. It's a bit awkward because I'm chair, and I have presentation, so I was asking Tommy to help me, and he kindly did it. All right, my today's presentation is just try to share some of the ongoing project with you, which is slightly still on the topic of structural health monitoring, more or less, but then there was a bit different issue here. So first, my outline of my presentation would be that I give you some overview of this project, and I also want to share with you our understanding of the challenge and also what is laid down for the methodology, and then some results and findings. Quite interesting. We can have a look. First, I would like to, you see, I put my name out there because we have a large team here. We have 5 PhD students and a bunch of academics, including myself. That's from UTS team. We also luckily have our partner from the Transport for New South Wales, and leading by the director, Dr. Crystal Dula, and was initially leading by the RA and the previous director. So let's see what is the problem we're facing. And the problem is so-called ASR problem, and ASR stands for the alkaline silicon reaction. It's quite an interesting phenomenon, and Australia will have a problem with that, not as severe as other countries like Canada and Europe, as well as America. So what really happened is when we have reactive aggregates and mainly contain the silicon, and then we have alkaline, mainly is sodium, the potassium, and when they work together and they form this kind of the interesting gel, we call it alkaline silicon gel. This gel around the aggregate and under influence of the moisture, and they start swollen, expand. And this expansion is quite significant. And as a result of expansion, you create the internal crack and so become external crack. And you can see in this diagram and the level of expansion and without silicon, alkaline silicon reaction with silicon reaction, there would be quite significant difference. So what that want to do with this? Okay, let's just narrow down, and for them, this is more serious problem even than the bridge. Let's just focus on the bridge, which is what this project is about. And we take 3 examples, one from Canada, overpass on the highway bridge, and you can see what it looks like, quite devastating. It's not as bad as it looks, but it is quite scary. And then we can also look at in Denmark, and for the pre-stress, the beam, and for many bridges we have like that, and how they form the cracking, and mainly a longitudinal cracking. And of course, another example is from our very old and the state and New South Wales, and this is part of our project. And actually, I personally went there and to the home book, and we took those pictures, and this is starting our project. So in terms of research, what we are looking at now, we probably by now you understand the ASR issues we have, and then AS issue for engineer, we have 2 folders, and one is to address the issue by prevent this phenomenon. So this is more interesting to the material supply construction companies. And in our university, not our team, but as a part of group, and we also have team work on that one prevention and look at what kind of level, lowest level, the highest level we can put in terms of the reactive, the aggregate. But for our project, we focus on the other end, which is more interest to asset owner. Let's say if we have already problem and we have built a bridge with those ASR problem pumps up, so what are we gonna do? Okay, so it's basically managing the structure affected by ASR. So that is the focus of our project. In this, excuse me, in this problem, there were two main elements. One is, as we said, expansion. And the second one is material deterioration. Okay, those are caused by the cracking, of course, because gel expansion under the influence of the moisture. And then how that one affecting our load carry capacity and how that affecting loss performance in terms of so many crack and also the further deterioration on the rebar or those reinforcement. And so those are the issues we need to look at it. From engineering perspective, let's imagine and you've been given an opportunity and to do research and have a bridge which is affected by ASR, as you can see here. And then you go there and you were asked by Transport for New South Wales to evaluate the state of performance as well as in terms of the safety and functionality. And then what they expect is, okay, you said it's safe, it's functional, so fine, and you probably like to continue monitoring it to see the change of performance. That's what we're planning to do. And but if it's no, what is, your action, what you're going to repair it or replace it? Those decisions have been made, and those decisions also depend on how quick they will deteriorate further, and if it's still safe now, and or if it's finishing few months, it's no point in monitoring anymore. So anyway, so those are issues we're facing. Under this issue, let's say we have a structure affected by ASR. That basically cause is a chemical reaction. It's not our concern because we are the structure engineer. So we look at the physical changes. So if the chemical reaction does not cause physical change, and that possibly is not major concern for us. But then what we do is, if there is change, can we observe those changes? Can we quantify this change? Without doing, if we can't, answer is no, and then we have little to do. But the answer is yes, then we have a lot of things to do. But in order to say yes itself is research. So this is basically the scope of the work, and we look at it. So including all constitution modeling we'll see later on, and uncertainty modeling and residue capacity, and also develop software to assess it, and the measurement and so on, and a new method to assessing it. So modeling, experimental investigation, that's the main part. So again, let's emphasize this is what we're planning to do. Remember, our natural problem is time and spatial dependent. So let's go back to traditional ways to do it. So we have two issues here. One is we want to know expansion. So how much expand, and that's very important, we'll see later on. And how can we monitor it and measure it? Second one is material deterioration, how do we do it? Remember, this is an existing structure affected by AR. It's not affecting yesterday and normally 20 years or more, or 10 years at least. So how do we do it? The traditional way, actually, we don't have initial measurement, so you don't know how much expanded. So they use a crack measurement. You can see this, how they do it, and from the experience empirical modeling, you will be able to figure out something better than nothing. So that's the state of art at the moment, how we evaluate it. For the material property, of course, we can take a core and drill and extract a core and to look at the material property. We will have a lot of issue and on that one too. But that's what we have at this stage. Okay, so realize, excuse me, delay. This is a bridge, Homebrook Bridge in just close to the border of New South Wales of Victoria, and then this is a pre-stressed concrete bridge, and then it affected by ASR. bridge has been built, the new bridge has been built, and this component has been taken out. We keep some and keep research on it. You need to realize two issues here. One is progressive nature. Second one is not even distributed nature. So when you're doing modeling, those things has to be part of it. Otherwise, you won't get the right result. But unfortunately, the problem we probably need to look at it is what kind of measurement we can get. Because numerical modeling, you can do whatever you like, and we'll see later. But you do need to have an adequate measurement, what you can measure to input. So this is a conceptual framework we set for the project. I will make it quick because time limit. And so first is measurement. Second one is analysis evaluation. And those are the tools we could provide at this stage. Okay, so couple of main issue here, the cracking and the crack pattern, those are important because this is actually essence of the ground which ASR expansion happened. And this also the ground for changing for the material property. Okay, so how do we do that one? We look at it later. Once you know expansion and once you know the material property change and locally, and then you will be able to establish your numerical modeling. Of course, you need to establish your constitutional law because this is a bit unusual problem because self-expansion on the constraint. So on this project, I have to say, unfortunately, because the COVID problem, we do have a little bit of issues and in terms of the experiment side and the field investigation side. But anyway, we did what we can do. So idea is if we digitize those pattern, crack pattern, and use whatever the mean we have and robotic or whatever and the human, and then we'll be able to derive the index for the material property. In the meantime, we'll be able to calculate expansion because that's what we do at the moment manually, but we can do much better than manually. And also we can use new non-destructive technique or testing and to really work out what material property in situ. That's also a possibility. We can also extract in the core and then to verify those information. At the end of the day, when we have expansion information and local material property, modeling become easy, and then we can work out the capacity and also predict the future. I will quickly introduce the different progress of the part of the project. Basically orient on the student and PhD project. So first project is by Attila and supervised by three supervisors. One of them moved to Canada, and then it's on the constitution modeling that side. So the development we have made is, okay, typically we have plastic model and then we coupled with damage model. So your damage actually will, so plastic will, if you look at this model here, you will see the plastic deformation, permanent deformation. But when you have a damage, your slope, which is the stiffness, will change because damage. So those are the phenomenological model. It can be calibrated and based on your experiment data and then applied for the structure, so from material to the structure. And then we combine this model together. So this is the model has been published. Now we published, it's new novelty there. And then when we go with ASR effect, which is expansion, volumetric expansion, but expansion also will cause deterioration. That's a coupled effect. And then build in to work out the actually result. So just quickly show you this, those couple unique things. One is the coupled elastoplastic model, damage model itself already capable to do the tension and compression. And the dotted line is experiment work, and the model can fit pretty well. This also can simulate the deterioration, and because of the softening when you keep loading, fatigue effect. And then second one is we face a challenge because durability problem take a long time to observe it. And we use a lot of the other people's data, but we also want to have our own data. So we actually develop a accelerated method. And that is not easy because we have to answer many questions and to to prove that it's correct. So this is the other part of the project doing that one. And with that, we'll be able to correlate crack pattern and the deterioration expansion altogether. And we also have done some work on expansion modeling. So expansion modeling, and there were certain issues, laboratory modeling and compared with the field modeling. And then the new model has been developed and taking the leaching effect or spatial effect, very jargon, and basically correlate laboratory result to field result and through this thermodynamic based modeling. And then we also are able with the contribution modeling to calculate reinforced beams result. You can see result present pretty well. And unfortunately, most data we get from our partner and from Canada. And so because we cannot do it because current situation. And we also have done some work and on the two ends. One is to improve relationship between expansion to material deterioration, because once we know expansion, we want to know how much material deteriorates, and use the machine learning, and it proved to be quite effective. Another one is computational homogeneous model approach to consider the crack, but in the homogeneous way and to work out. So this also has been effective. And then at the end, and those results will be combined with the Abacus in this case, or Attila, computer software, the fundamental element software, and to work out the performance of or capacity of the structure affected by ASR, but in the probabilistic way. And also I need to point out, we also not conclusively made some progress and on the crack identification and use AI model, and as you can see, and the raw image and the traditional method processed, and then what you can do. Those quality are very important because crack width is of interest here, and not only orientation. And as we said, another important point for our project is to explore whether use piezoelectric disc sensor to calculate to measure the mechanical property in situ. And so this is done whether in bed or retrofit, doesn't matter. And the idea here is to send in the modulator wave. One is we call the pumping wave, which is open close crack. And one is actually measuring wave, investigation wave, which we call probing wave. So basically you will make crack breathe, which is open, close, and then you measure it. And work is still ongoing, but it's quite promising. And for single crack, it's a little bit hard, but for multiple crack, actually is more effective. Interesting. All right, because time limit, I probably stop my presentation. But before I stop, I would like to acknowledge beside the team and also acknowledge Nanacom ARC Hub and to support the research and also the Transport for New South Wales.
Okay, so thank you so much, John. So because of the time, I can allow one question. If is there any question? Anyone who would like to ask, then they can put it down. So it seems that under the chat, under the Q&A, you have no questions. So thank you so much. So we can leave it to, okay, I leave it to you, Jianchun. So you please share.
Thank you, Tommy.